Yeah, so hi, I'm Jonathan Brown. I'm a software engineer at Democracy Works, and I'm here to talk about my experiences with Spark and share that with y'all. And just for a little bit of background, I suspect sometimes that I must be a Russian bot because my job is to meddle with American elections. We are a nonprofit whose goal is to increase voter registration, and we provide tools to help voters do so in their local area. So it's a lot of dealing with local legislation and building software to model that. Here's what we're going to cover today. We'll try to get through it in the time available. There's just sort of an overview of when and why you would use these tools, the ecosystem you can choose from for them, and I'll work through a small example of how you might use Spark and Clojure, and then get into the fun part of making your code go live. This is the first thing to think about when you think you might have big data, is do you actually have big data? And people sometimes think they do, because it's fun. I wish I had big data. Everyone wants theirs to be bigger. It's great. You can get more insights. You can train your models better and all that. But yeah, once you're, the general heuristic is that once you're at the point that one computer can't handle the data anymore, it's getting into big data range. And this is once you get into about the 100 gigabyte to terabyte range. That's when tools like Spark come into play. So most of these systems, the current state of the art, I suppose, is heavily influenced by this paper that came out of Google called MapReduce. Sort of set the landscape for the next decade plus of distributed computing tools. Spark is one of them. Spark doesn't necessarily, yeah, it does. It depends on Hadoop. We use a lot. There's sort of a local mode, but it's a Hadoop-based tool. And this is what MapReduce is. This is what most of these systems are doing something similar to. The idea is that just about any program can be written, program tightly defined, say, can be written by mapping over your data, transforming them, doing some groupings on the data, and then maybe some aggregations. Program in this context is almost analogous to query. The idea is that you have some input rows and you're transforming them. So MapReduce is the concept. Hadoop had an internal version of it. They wrote MapReduce, shared a paper, someone implemented MapReduce. And it's just a tool for managing cluster resources. You have end computers, you have your data on them, and you want to run computations over that. So later, Yarn was developed as a component of Hadoop, just as a manager for computing resources. It's not an operating system. It does operating system-like things at the cluster level of allocating computation time, allocating memory, and other tools came along to take advantage of as well. This is Yarn. Yarn manages the resources on the cluster. It has a single leader node and a collection of containers. Containers have sizes. It allocates resources on the cluster to run user programs. Spark uses Yarn. Spark, we shall see, has a variety of cluster managers, and Yarn is one of them. It's the earliest one. Is everybody with me so far? Also, I just want to know, I'm curious, what are people's level of experience, thoughts, feelings, impressions of Spark? Is it totally alien, heard of, used? Native.
Used it, don't like it.
Me too. I'm going to talk about Onyx a bit too. Has anyone seen Onyx?
Yes.
Yeah. I pity the guy isn't currently developed. Are you here? Okay, so Spark. Spark is the big one. Spark is what we have nowadays for when you really need to process your terabytes of data. It's originally developed at UC Berkeley. There's a stack of libraries for doing the different sorts of data processing that people want to do, and there's a variety of platforms it can run on. So Spark is sort of an abstraction layer for writing programs that run on large clusters, and it's capable of running on a few different types of clusters. So the key interaction with the cluster is the allocation of resources. There's basically containers. Your application is going to have a driver. It's going to have a master node, and it's going to have n worker nodes that do the computation over the data, and they're all basically containers. So it has some things that it can do. It does machine learning. It does graph queries. And that's all sort of additional libraries based on the same platform. The concepts we're going to use a couple times are the driver program, which is your master node, and it's handling the initialization. It's written as just like initializing a connection to the cluster, and will contact the cluster, provision resources, and run the rest of the program. So now we're getting into Spark. And in Spark, the way that it represents data is something called an RDD, Resilient Distributed Data Set. This is a fundamental Spark abstraction. The other things on top of it, the data frames and the data sets, are syntactic sugar might be a strong word, but they're conveniences, they're affordances over the RDD. One of the important ones that comes up a lot is a pair RDD. It's key values. It's not unique key values in the sense of like a Clojure map, but it's keys and values, and there are tools in Spark to operate on these keys, to group by the keys, and do so efficiently. So here's an example of Spark creating a pair RDD. This could be a small Spark program where your data is this list of just 4 words, and you create a pair RDD. Just adding a 1 for each word. And now you have an RDD of string and int. Yeah, okay, so the thing about pair RDDs is that it's a regular RDD where the rows are Scala tuples. Spark's written in Scala. Everything underneath is going to be Scala tuples, and the tools that work with it will have facilities for converting between the language's native data type and Scala. On these RDDs, you can do things. You can do transformations, which are lazy, and you can do actions, which are not lazy, are eager, which return a value to the driver program. Things like, it's fairly intuitive. Things that you would expect to be lazy will usually be lazy. There's like mapping. It doesn't usually do the eager computation until it needs to, until you expect the result to be, say, a single number rather than a collection. That's what Spark is. I know how everyone's feeling right now. So this is Clojure. Clojure does a lot of these same things. There's a few other libraries in Clojure, some of them for interacting with Spark because it's kind of the big player, and because we're a language community full of smart people with big ambitions, there's some options as well. Onyx looks great. I'm keeping my eye on that. And there was a thing a few years ago that Netflix wrote called Pigpen, which is a compiler from Clojure to Pig. Hasn't really been updated recently. Also, PowderKeg looked really nice. Christoph Grand is working on it, and the goal was just to provide ever faster, more seamless REPL-driven development. But today we're going to talk about sparkling, because sparkling is sort of a straightforward interop layer to provide a Clojure language API to Spark. So this is the same program, the same Spark program that was in Scala earlier as a Clojure program. We have a vector, we convert it to a Spark RDD with a parallelized function. Map to pair is a function which creates a pair RDD from Scala tuples. And we're going to do a little example on this data. I found some data about Brooklyn real estate. And there's other columns, but these are the interesting columns. It's this sort of thing. It's a log of real estate transactions. This building was sold for this much on this date, and it has some attributes about the building. It's only about Brooklyn. That was the data set that they had, which is also where Democracy Works is located. We're going to try and find the most valuable real estate in Brooklyn, just out of curiosity. You could do other things too. You could maybe try and build a predictive model of a particular place, what the transaction would be. This is not a machine learning talk. This is a data engineering talk. So we're going to try and find the most valuable real estate in Brooklyn. And it's broken down into zip codes. And we'll just do a little quick Spark task over the data to find that out. So this is the type of thing that our program will be doing. Cleaning and extracting the rows, grouping them by zip code, doing an aggregation on each zip code, and then finding the result for the one that we want. There's a little bit of boilerplate to have a Spark program. Import your libraries. There's a thing called a Spark context, which is just the object that handles connecting to the cluster and getting your program its resources. There's a little bit of scope weirdness, I guess. But a nice thing about being in an immutable language, like if we were to say have an atom at the top level of this namespace and then access it in our mapping functions, that would be a very bad idea because it's not even on the same machine anymore. But with an immutable language, it does handle serializing the function's closed scope and sending it to the nodes. So here's the part that extracts the data. It's just CSV, so this works for, all you have to do is split on string. But if it was some other data format, there's readers that exist. We're just using the basic text reader. The thing about the data is it needs to be accessible from all the nodes. It needs to, so S3 is common. Maybe you're also running Hadoop on the same nodes as Spark, and then you can access the data that way. And this is the part that's happening on the worker nodes. Just sort of, oh yeah, so here's the first part where we read in the CSV, and then all we do here is compute the price per square foot of each transaction. So these records are extracted down. It's just a map over each row that ends up with a pair of zip code and price per square foot. And there's what's actually a map, so we can sum the n as well, because we're going to do an average. And so here, now we're going to find the averages. Do you like my little poor man's code collapsing? Right. So then this is just computing an average for each zip code. Everything so far is still RDDs. The part where we're let sale records and let zip average, these are transformations. So if we just did that and didn't have the print, nothing would get computed really in this program. Max is an action because it's getting a single value out of the whole cluster. So it's going to create what Spark does internally is it creates a DAG of the computations that need to happen and sorts that out before actually computing the value. Turns out Brighton Beach is the most valuable real estate in Brooklyn by price per square foot. Shocking to everyone. Didn't have questions so far?
Do that stuff in the REPL, or is there still weird serialization issues?
You can do it in the REPL. The nice thing about Spark, you might need to use less data to do it in the REPL. The nice thing about Spark is that it has a local mode that can run over small data sets. Everything that I did here, like this, to develop this program, the main, instead of a main originally, I just had comment, and I was doing my little evals in Emacs. You can, theoretically, you can, instead of running your REPL in local mode, you could run it as a driver program. That'd be fun to see what happens. Question? Yes?
What are the advantages of Spark over Onyx?
Over Onyx? Spark is basically, I haven't used Onyx personally. It seems super interesting, and I want to try it out as soon as possible. But I would say the advantage of Spark is that it's more reliable. It's been in use much longer. And yeah, I'm not sure what level of support or what level of support Onyx has.
Do you have this example that you kind of demonstrate anywhere on GitHub, maybe in KISS, something that we could have?
I can share it. I can absolutely share it. It's very similar. It's very similar to the example on Sparkling's webpage.
So that was the follow-up question. Is it similar to what Sparkling does?
Yeah. Maybe probably the main interesting thing that I did for it is just to get it to work with the latest, newer versions of Spark and Hadoop. Because we're going to get to that, the real trick with this stuff. So as you can see, it's fairly, if you know how to write MapReduce and functional programs, it's pretty great. You have a lot of data, you write your functional program, and it operates on the data. The trick really comes with deploys and operations. This is what. Yeah, in my experience, and it sounds like maybe everyone else, that's been the real trick with this stuff. Yeah. Ideally, this wouldn't even be a one person. It's kind of a big stack to be the application programmer on here and responsible for a Spark cluster and a Kubernetes cluster. So it gets to be a lot. So you've got your data and you've got a program, and maybe you've tried it out on a few dozen megabytes, and now you want to run it on your petabytes. And so this is the big picture of how you make that happen. You get it. You need there to be a cluster. You need Spark to be on the cluster. And then you need to submit your program to the smart cluster. And then this happens. It's a big one. Because when you compile your Clojure program, Spark and Hadoop are provided dependencies. So your application is compiled against them, but you don't include them in the jar. They're on the cluster already, so you need these versions to match. And then something doesn't work in that version, and you need to upgrade it, and then you also need to upgrade it on the cluster, and it conflicts with something there. Just a sort of illustration of provisioning the cluster. It comes down to your choice of cluster manager. You can run a standalone cluster. Spark will do this. Has built-in components for it. It can run on Mesos. It can run on Yarn. It can run on Kubernetes. EMR provides clusters. that are Yarn clusters, which I don't recommend because of issues related to all the versions that you're going to want. Personally, I think Kubernetes is the simplest option at the moment. The newer versions of Spark, starting with 2.3, have the ability to built into it. When you download Spark, it comes with a script that creates a Docker file, and another script that creates pods in Kubernetes running Spark on that Docker image that it created. That's how I felt about those. We're in Canada, so. This is what deploying your Spark job to the cluster. You'll create an Uber jar just with a normal Leiningen project, unless someone's using boot. And yeah, so Spark is set up that it's a JVM project, right? So we got that going for us. And Spark is set up that it accepts a jar and a pointer to a class in that jar and runs the program in there. So your program has a main, and assuming you've lined up all the versions correctly, Spark will accept your jar. The jar also needs to be available across the cluster. So it can't be just a path on your local file system. You're going to want it available over the network. Everyone looks good. It's fine. And then you get it. When it works, it's nice. You have written your program, you push your command, you force push, and it gets on the cluster, and it works. Any other questions? Wait.
How heavy is the Spark cluster in terms of resources? Like, is it feasible to potentially run a project, redeploy an entire Spark cluster on a Kubernetes cluster? And if so, is there anything that's doing like library management, Clojure, anything around that?
That's a good question. It's fairly heavy. So if you want, the way that I've been experimenting with it is using Minikube to run a single Spark cluster, and you're going to want at least 8 gigabytes of memory for that. You could, right, so if your projects have separate dependencies, you might need different Spark clusters. It is an option, if possible. You can put your dependencies in your applications jar. You don't, so depending on what sort of thing they are, if they're Hadoop integrated dependencies, you'll want them to be included with Spark, but other dependencies can just be in your applications jar. Other questions?
I was just wondering, I had some experience using this many years ago. I got to strange points where there were serialization issues that, as best I could tell, we were just like too deep inside of a macro, layers of macros. I'm not exactly sure because we would make small changes to the code and it would just go away. And I was wondering if you ever saw something similar. Just like bizarre things that with no real explanation except, move code around, move it into a new namespace, and then that would sometimes fix it.
I mean, I've seen some bizarre things. One of the most common things that I feel like comes up is weird combinations of dependencies, especially to do with the Amazon client libraries. Like, yeah, don't be afraid to, this is the next slide, don't be afraid to twiddle the sub-dependencies of your projects. Something that came up for me a lot is like, so like, this project is bringing in this project that brings in an older version of this library, and now maybe it's hacky or not the right thing to do, but it works when you just promote it to a top-level dependency and specify that's the one that should be in it. As far as like the actual macro serialization issues, I didn't encounter that exact issue. But yeah, it sounds weird.
I've only used Spark from Java.
So you definitely want to use gen class in your Clojure code. I did not run into needing to configure the Cairo serializer. All right, yeah. So yeah, thanks, guys. It's great sharing this with you. If you want to learn more, there's some links here. The sparkling documentations are fairly thorough for the application development side of things, and their example is mostly what I pulled this code from. Thank you.